unit number second. So your unit number second, beta, it's basically is related to, we can say, it is related to more about the historical background of your grid computing, plus some other concepts. Fine. So just give me 1 second. I am sharing my screen with you, and please let me know if you are able to see it or not. Beta, see, are you able to see the screen?
Yes, ma'am.
Okay, so here we are having the things more related to your history. So first one is motivation. Whenever I am using the word motivation, what does you mean by that? Motivation means, beta, suppose if you have to do something, what is inspiring you to do that thing? In layman term, if I'm saying, or we can say there is something I'm saying, okay, can you tell me, Lakshay, which phone you are using, beta?
Ma'am, it is Moto G5S.
Okay, so may I know, beta, your specific reason why you choose or opted this specific model? Any reason?
Yes, ma'am, because it has a fingerprint sensor in the front, so it is easy to unlock and दोबारा lock करने के भी easy रहता है.
Okay, so for Lakshya, the main motivation is the ease in use of fingerprint in the phone. Fine. So whatever you are doing or whatever you plan to do, you are inspired by some things. You are motivated by some things. So same here when we are using the grid. So what are the motivation ki we opted the grid computing? So few motivation I have noted here. So first one is whenever we are having your grid. So your grid up is allowing us that we can, we can use software applications. Fine, we are having multiple applications, and using that we are combining your different instruments in the sense they can be your computers, they can be other scientific instruments, they can be your your screens where you are displaying your result, they can be your processing unit where you are doing the computation, they can be the memory, they can be the resources, they can be anything. Fine. So here in grid, this is this is possible that suppose we are having different things at different location. Fine. Suppose I can say you are, in general example, if I'm taking, let us say we are having one medical test. Fine. So that test, taking the sample for this, that test is easy. But if that test require a machine in, in which the test results are evaluated. So that machine is, let us say, it is so situated only in few city of India. Like we can say it is in Delhi, it is in Bangalore, it is in Mumbai, in some few locations. So what we did, we have to send the sample to these location where the lab is situated. Fine, where the lab is having that particular machine. So same here, whenever we are working with the system, so it may be possible a few things may be situated in one lab, another may be situated in another lab, and we want to use all of them, and they're physically at a distant location. So you cannot say ki you suppose you want to use resource one and it is situated in Delhi. One day you will be staying in Delhi, another day you are going to Bangalore to use the resource number second. So we cannot do that. So to use the resources that are geographically at distant location, your grid enable us to use them in a secure way. Fine. Next, beta, what we can have? We can have the another possible advantage that your organizations can share their computing power. They can share their computing resources. They can even share their databases, or they can even have the tools that are secure, providing the security to all the corporates, to all the institutes, or to all the organizations that are using your grid. Let us take one example. uh, Suppose let us take Khushi is going for a vacation. Fine. Khushi is having her ATM. So let us say she has some, she want to purchase something, or she want to pay the hotel bill. So she is swiping her card, or maybe she is using the ATM there. Fine. So whenever, let us say she has swiped her card for bill payment of the hotel, she swiped the card for shopping, and two, three places she had swiped. So whenever she is swiping the card, all the the transaction that she is carrying out with her account, they are reflected immediately to each and every bank. Am I right? Yes or no, beta?
Yes, ma'am.
Fine. In another way, if I'm saying, you suppose if you are having a card, ATM card of SBI Bank. Fine. You can even use the, suppose you are going somewhere and you are not able to find the ATM of SBI Bank. You can use the PNB Bank. How PNB Bank knows about your account detail? How they know what is the exact amount in your account? How they are changing, although you are the, or you have your account in SBI, so they know how they are able to access all this detail or all this knowledge. So because they are sharing their knowledge, each and every bank is sharing their data with each other. Fine. So if they are not sharing, you are not able to access your your ATM from some other bank ATM branch. So this is just a simple example. So in such scenario, if we are implementing your grid, they will be very beneficial. Fine. Now another thing, it may be possible, like beta, if I'm talking about the big companies like IBM, Samsung, Apple, these companies are having their own research department, in the sense they have a separate department that is only involved in improving the existing technology. They are always busy in trying to identify or invent new things, trying to improve the technology. So now you have the idea, like if I'm saying about the Samsung. So Samsung is not situated in a single country. They are having their their branches all over the world. Even within inside a country, they are having two or more than that. Maybe you can find one in Noida, maybe you can find one in Bangalore, within India. So in this way, what we are having so many branches that are geographically apart. Now all of the branches, or we can say two or three branches, are cooperated together, and they are working on the same task. Each day they are doing something. At the end of the day, they have to share what they have done, so that they know what is the current status of their work. So this can be done by using your grid. They can be communicated through the grid. They can share their result through the grids. So here grids allow us that motivates us in such cases, that if we have different organizations situated at different location, and they are working on some specific things, so they can combine and they can share their things with each other. Fine. Next, Vita, here in grid, I already told you we are able to identify the resource. We can discover the resources. Like we can identify which CPU is idle, and we can use that CPU. Fine. So we can identify in the same way which resource is being used by which device, or which is empty, or in this way we can use the resources also. So whatever the application, the application, they are all almost your motivations are related to those. Better the motivation point is clear to everyone. See the slide and tell me if you have any doubt and problem.
Yes, ma'am, clear.
Okay, fine. So in the next slide, what we are having the benefits. Benefits here, benefits is a vast term. Here we have only listed the benefits that are according to the company perspective. Fine. Means how a grid is benefiting a company or an industry. So here only four benefits we have point out. They are just related to your industry. So your first one is grid are increasing your productivity gain. Fine, how the productivity is increased? It is increased by because it is flexible. Flexible in the sense, beta, anything is flexible. If I am saying, if it is easy for to extend or to you know reduce the size. For example, you are having a network. If you are easy to add 3 or 4 or 10 system as per your requirement, and whenever you think, okay, now your requirement is less, so you can just remove them. So we can say that is flexible. Fine. And second thing is, within how much time you can add those new machines. So what is the speed of deployment? Like for example, let us say Rhythm is running a small organization. Fine. Where we can say she is a, just in simple way, let's say she is manufacturing LED bulb. Fine. So she is currently producing, let us say her regular production is around 1,000. Fine. She is having this production with 10 workers. Now she got a new one, and she has to deliver, 1,000 more to a customer. Regularly, she has delivered 1,000 additional ones. So what she requires? She requires more manpower. Now, if if there is the flexibility, she can recruit the 10 new workers. Fine. Depending upon, they can be like, they can be professional. They know how to how to create them, or it may be possible they are freshers. Fine. And second thing, within how many days she can recruit? Now she is having the high production demand, so she just have more worker. When she feel like her project is completed, she is not getting more uh, more demand. So what she will do, she will just reduce the number of workers. So this is the one way when we are related the flexibility to your day-to-day life. So here also, in your grid, it is easier for us to include the new nodes or new resources whenever it is needed. Fine. And we can also remove them whenever we think we don't require. Like for example, if we are having a very high competition, you are working with 150 systems. Now you think 150 systems are not sufficient, so you add 50 more or maybe 100. Next time you think, okay, your competition is not that much bulky, so what you will do, you can remove those additional systems. Fine. Next, second important benefit that grid provides to your company is they provide the massive computing power. Means we can perform very large computing. We can perform the scientific computing also here. So they are providing the massive computing power to you. Next, we can work in collaboration. Collaboration means in your two different companies, two different industry, they can combine and they can work, or even maybe possible two different branches of a single company can collaborate and can work. So it is allowing the collaboration, means it is allowing us to work together. Finally, it is cost saving. Cost saving in the sense it reduce your overall cost. I already explained you, like Suppose if you have to implement a lab, that lab is working on scientific data, very large scientific data. Suppose you are working on some astronomical data, you have to evaluate some distance, or you are working on planets, their distance, their circumference, their radius. You have the idea there the number is very very large, or even the values are counted in decimals, or sometimes it is important that we are counting the number 10 digits, we are counting after decimal also. So in that case, suppose initially you are using supercomputers. So supercomputers are very costly. So we can replace that supercomputer by hundreds or 150 or 200 CPUs or processors, and then we can do the same computing. So in that case, our cost will be reduced. We are saving the overall cost. So these are with some of the benefits. Have a look on the benefits. If you have any doubt, please let me know.
No, ma'am.
Okay, so next we are moving towards your, this is not a part of your syllabus, just for your knowledge, I am telling you about this slide. So whenever we are having some technology, basically they have some forum, or they have some consortiums. These kind of forum or consortium, they are continuously working for, to improve that technology. Fine. For everyone, mostly they have their own consortium or forum. For big data, you can find out some. For your, for your TCP/IP protocol, sorry, OSI model, that is also having a consortium or forum. So here also we are having. So these are some consortium or forum like Asian Pacific Grid, Australian Grid Forum, Distributed.net, eGrid. Then you have your Global Grid Forum. So these are some. Fine. So this is just for your knowledge and for your this is out of your syllabus. So you can just to read it for your name knowledge. You can just go through the names of each and every forum. But when you are done with the slide, please let me know. I'll go to the next slide.
Yes, ma'am.
Okay, so let's move to the next slide. Next topic is your history. So whenever we are talking about the history, your history is divided in terms of like history of grid, history of networking and computing. So many things we are having. So we are not dealing with the single history. So first, I'm talking about the networking and computing, ki how your networking and computing evolves. So this is the diagram. Initially, we are having simple networking, like our main motive is to transfer information between two different systems. Then the main networking concept arise when we have, propose your TCP/IP protocol. So you have the knowledge about the TCP/IP protocol, yes or no?
Yes, ma'am.
Can you tell me, Vita, why we use your TCP/IP protocol? What are their main requirements or functioning they are doing?
Don't remember.
Can you be a little bit loud, Lakshay?
Ma'am, don't remember
Okay, so if you
clearly.
remember, I'm just giving you a basic overview. I'm not going in the detail of that. Whenever you are transferring data from one system to another in a network, so TCP/IP protocol tell us how the information is transferred. If you remember, in your IP protocol, you have studied IP version like IPv4, IPv6. They have the complete thing like if you have a data packet that will be divided into this bit contain this header and all this thing. I'm not going in the details, so I'm just giving you a brief overview. if you are going, you have to share the data. So how the data is shared, what are the rules or what are the procedure it will follow, that will be explained by your TCP/IP protocol. Fine. So that is a part of your computer network. Fine. So initially we have the basic networks. Then from that basic network, we understand ki, okay, we have multiple devices. So how the data should be transferred. So with the enhancement or with the improvement, we conclude your TCP/IP protocol. Next, after then we have your we try to communicate. We thought why we cannot have a digital communication in between two users, not in between the two system, but in between the two users also. So what we have then, we introduce your internet and we have your email type, and where you are sending your emails. So this is the way when your the digital message transfer from one to another system. Okay, now we have so many ways to transfer messages. Like see, a simple example is your WhatsApp messages or your messenger. Fine. So initially it start with the email. Next, Vita, you have the information time. Information time means when we develop the websites, where the website is providing information about the things. Like suppose if you are conducting an event, so you can put the information about the event on the website. For example, if any university is having any event, like they have any kind of technical event or anything, so they can display that on their website. Fine. So then the time of information came, means we identify the need to develop the web. We have the internet, so why we cannot use it internet to share knowledge or to share the information? So we develop web pages. They can be for anything. Like you can create a web page for for any advertisement purpose. Next, you can have a web page for, like, you are providing some educational information. You write a blog describing about some technique, so that is information. Everything is on the website. So after the information, we what we think, why we cannot share the resources on the network. Fine. So from starting from the network, with the requirement, as the requirement change, we have changed the technique. So finally we have the computing, that is your grid. So in grid we are sharing your resources over a network. Is it these four phases are clear to you? So the first one is your networking phase, then we have your communication time, then we have your information, and then finally we have your computing. Just
Yes,
see
ma'am.
the stack carefully. If you have any doubt, you can tell me.
No, ma'am.
Okay, so next we have, see, this is the historical diagram that is representing from 1965 to 2005. They have included up to 2005 in your book. So what are the things that are, that we can see there are introduced in your computing and in your communication. So first see the below diagram, that is for networking, like for your communication. Initially, when your networking start, around 65, we have your packet switching. Means you are transferring your data in terms of packet. Then after packet switching, we have your ARPANET. You have any idea about the ARPANET? Class, had you ever read this term ARPANET? Okay, had you
Yes, ma'am.
read
In
internet?
subject web technology.
Pardon, Lakshya, can you repeat again?
Yes, ma'am. In subject web technology.
Okay. What happened, beta, when uh, if you have studied the internet, fine. So ARPANET is the starting of your internet. This is the first project that we can say is implemented to connect through a networks, where we are connecting three, four, or many nodes to one network. So initially, this this is having four nodes, four different. One is, I guess, one is a university. I don't remember the exactly four nodes, but they are, but four different places, four different things. They are connected together, and they started the ARPANET. Fine. So ARPANET is, you can say, this is the starting from where your internet was founded through this ARPANET. Fine. So next, when we have the ARPANET, means your initially four different sites or four different organizations are connected together through a network that is known as your ARPANET. Then we identify, okay, if we want to communicate through a network, so then we introduce the email. Then after that, we have your LANs and Ethernet. LAN and Ethernet, you have the idea, like we are connecting several systems within a small geographical location. Then after that, we introduce your TCP/IP. Fine. So with that, we have your Bell system. They are also having their own networks. So many networks we are having. Then after email, you have your SGML, you have your HTML, you have your IETF, then means from 90 to 2000, if we are talking about, in between 90 to 2000, within the gap of 10 years, different organization or different people are introducing different things. Like your www was introduced, World Wide Web it was introduced. Same side, we have your HTML. Then after some time, we identify the broadband. Then we switched from wired network, we switched to the wireless network. After sometimes, initially your broadband speed is limited. Fine. Next, we realize, okay, we want more speed. So technology related to your speeding, they will be improved. We have your fiber channel, we have your fiber optical cables now. So many things change side by side. Fine. So this is related to your communication. Next is your computing. So computing, you understand a little bit late. So what we have your computing means it's basically find its root when you have your time sharing system. Time sharing means, do you have any idea about time sharing?
Yes, ma'am.
Can you explain, Kushi?
Ma'am, there are different processes and they share equal amount of time for executing the process, and then they'll switch again after a fixed amount of time. So that is a kind of time sharing.
Correct. Initially, what happened when we are having your batch systems, or they have their job. So, job will execute one by one. Fine. One job is executed. After its completion, your second will execute. So, in that way, you have to wait for a longer time. But what we realize, in that situation, your CPU is not properly utilized. So we have your time sharing. Time sharing allows us, suppose what we are having, you have all read about the round robin scheduling, where we have given a specific time as a time slice, like I can say 10 nanosecond or 10 second. So 10 second, the processor is given to one process. Next 10 second, it will be given to process number second. Next 10 second, it will be given to process number third, and so on. So what is the benefit in this way, beta? No process has to wait for a longer time. Every process think like they are solely using this processor. Or if Kushi is only using the processor, so she is having the illusion like only her process is executing. But we have multiple processes that are executed by the CPU. So with the time sharing system, we have started this concept. Next, we have your Unix. So Unix is basically your, your Linux. You can say similar to Linux, your operating system. that was originally created for, for computing related things. Next, we have your mini computers. They are replaced by your personal computers. Now your personal computers, when we are having, we reduce the size of computer. What we think, we have implemented the workstation, like how to connect 4, 5, 6 systems within a single workstation, or more than six system. Fine. So then we have your workstation. Uh, with the improvement in the Unix, we have your Linux. We have Linux like operating system. Then we have a term known as open source. So can you tell me, beta, what is open source? Open
And
source
that
Whatever
is
is
with
free
free
to use.
source is available.
correct. Any software or any resource that is freely available to you. It means you don't have to pay the fee to use that. So that is your open source. So we have some open source things also. For example, Unix is open source, beta. You don't have to pay anything for that. It is freely available. Ubuntu is freely available. Next, we at the end of 2000, we have a improvement in your, in before 2000 we have clustering, then up to 2000 we have an improvement. We introduce your grids. Within the 5 year gap, 5 or 6 year gap, we have your first generation of grid. We have then say 2G grids, we have your 3G grids. So we can say the grid technology improves so fastly that within 5 or 6 year gap, we introduce three different generation of grids. So this is about the grid. Let us have a look on this picture and then tell me, then we will go to the next slide.
Yes, ma'am.
Let's move to the next topic, or sorry, next slide. Okay, now we have divided your history in, in the different part, like communication history, grid history, sorry, computing history. So first is your communication. Communication, I already told you, the foundation of your internet is your ARPANET. Fine. So what happened? US Department of Defense Advanced Research Project Agency, that is termed as your DARPA. They started the internet as a research project, and they started this as the ARPANET. So initially they are having 4 nodes, 4 different organizations are connected through the this net. After that, we have more networks. They are introduced by different companies, but this is the first known network that we can say that is the foundation of your internet. Next, what we have in 78.4, we have your transmission control protocol, how your transmission will take place between 2 different nodes over a network that will be governed by your TCP. But after 4 years, to make it more simple, to make it more effective, we have divided this into 2 protocols, that is TCP and IP. Fine. So that is after the 4 year. Next, in around 80, your National Science Foundation, they created their own net that is known as their NSF net. With the late, you can say up to 90s, we have so many network around the world. where so many systems are connected through each other. Up to 90, within the 10 year we have so many net. Next, in the 86, we have your Internet Engineering Task Force, that is known as IETF. What they did, they form a they form a loosely self-organized group where where a number of people are combined, or we can say they are collaborating to work for the internet technology. Fine, so this is IETA. What they did, they have grouped some people that are having the knowledge related to internet technology. They work together, they combine together, and they, finally they implement or propose the uh, suggestions. They give the better technology. For example, like we have so many forums. What they did, they invite, they work in the same procedure. They invite the people to come to look into the code. If you find some bugs, please, modify the code and submit, or to improve the protocols, or to improve anything. So we have such kind of things already existing in the uh, world. Fine. So next major breakthrough is the invention of your WWW, that was invented by Tim Berners-Lee. Uh, they developed this, and developed this by keeping the view in the mind ki, okay, they have to share information. Fine. So now, whenever you are searching anything on the network, you have the idea we have www dot. Like without the this World Wide Web, you cannot do anything. So this according to me is a major thing that has been proposed in the world by the Tim Berners-Lee. Fine. Next, what we have your HTML. When we provide the HTML, with the help of that, now you are able to create the pages, web pages. Now you have so many. You can use XML and blah blah things are there, but your things of creating the web documents, it started with the HTML. So HTML can be considered as the foundation language, or the foundation way to create your web pages. Might be you have studied in any semester that how you can create a web page using the HTML. Have you studied better?
Yes, ma'am.
Fine. So you have the idea HTML is used to create the web pages. Next, what we have, then we have your WWW consortium. So it was developed in 94. Initially, it was WWW is introduced. Whenever you introduce something, we cannot say it is perfect. It requires some modification. It requires some changes with time. So then a consortium is formed in 94, just to develop new standard, how we can change the information, just to improve your World Wide Web. So the work for this consortium is only related to improving the www, or how you are sharing your information you know on the network. So they are designing, they are developing, they are improving your standards. Next, we have the next major important technique that have emerges your optical network. Beta, what are optical network? Have you any idea about them? Okay, optical network means, beta, optical word means कि you are using or you are transferring information in the form of light. App normally whatever the wiring you are using, they are having the electric current inside them. Fine. So आपका जो ट्रांसफर हो रहा है, that is in the form of electrical current. So ऑप्टिकल नेटवर्क्स आर बेसिकली, बेटा, आप इंफॉर्मेशन को ट्रांसफर करते हैं लाइट सिग्नल्स की फॉर्म में. बेनिफिट क्या होता है? दे हैव वेरी हाई स्पीड. कैन यू टेल मी द स्पीड ऑफ लाइट? बेटा, कैन यू टेल मी द स्पीड ऑफ लाइट इफ यू हैव एनी आइडिया? Beta, have you studied this in your physics?
Yes,
Yes,
ma'am.
ma'am.
It's
It's
like
around
10 to
3 into 10 to the power 8,
8.
correct? So it's
Yes, ma'am.
very, 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 we can say ki it's very fast. Aapki light, we can say it's travel very fast. So what we have done, we are using the fact, we are transferring information in terms of light signal. So जब बेटा ब्रॉडबैंड की या नेट की शुरुआत हुई थी, at that time your net is very costly. No one even can think to purchase the net pack. आपका मेजर यूनिवर्सिटीज में मेजर स्कूल्स में होता था, स्कूल्स में भी हर जगह नहीं होता था नेट, बट नाउ यू कैन सी network is available to each and every university, each and every college and each and every school. Why? Because the cost has reduced. Cost किस reason से reduce हुई? Because the technology have changed. So we are using now optical network. लाइक बेटा अगर मैं बात करूं, आपका एयरटेल है या बीएसएनएल है या जियो है, whatever we have, if they they want to transfer the broadband, they want to give you the broadband facility, so they generally use your optical fibers to transfer the data. What is the benefit of that? Benefit is that the service is providing a reasonable cost for your broadband connectivity. Now they are not that much cheap, costly as it was in the initial time. So they are using optical. SONET is beta synchronous optical network. Fine. Next, this is wavelength division multiplication, that is related to your transmission. We have different transmission techniques. So I'm not going in the detail of this dense wavelength division multiplexing. So when we have now, we have introduced better communication. We have better networking speed. So with that, what we have done, we have introduced the grid computing. This this allow us to use these properties to develop your grid computing. Better see this slide and tell me if this slide is clear to you or not. Better, can we switch to next slide?
Yes, ma'am.
Okay, next we will continue tomorrow. We will have your computation history. So what is in your computation history? Just give me 1 second. Are you able to see my screen?
Yes,
Yes,
ma'am.
Class,
ma'am.
I okay, just give me 1 second. Okay, computation history, it started from Multics. So this is an operating system that was developed by your MIT. Fine. So from there we have started your computational history. Then we think, okay, there are some machine cycles that are unused, or you can say some processor cycles are there that remain unused when your your process is busy in input output, doing the input output requests. So at that time your processor is idle. So what we think, why we why the our system remain idle? Processor should be working each and every time. So we have to develop something. We have to change our strategy the way that we can use your unused machine cycle. So for that, we try to link, computers in a network form. Like if one system is busy, another one is idle, so we can use the another one. If one machine is overloaded by, we cannot use the another one. So this is the idea behind the introduction of your data communication. How we are communicating your data throughout a network. Next, in 73, we have a research center that developed the program. That is a worm. So can anyone tell me what is a worm, beta? If I'm talking about the worm, so what does that mean? Beta, have you heard about the worm virus, malwares?
Yes, ma'am.
So worm is something, it is a program. Fine, what it will do, it will, you know, move from one system to another and then create its copy. Okay? And then it's use the system resources and just transmit its clone to next machine. So what is the disadvantage of using this? Can anyone tell me how they are affecting your your performance? See, suppose
And
beta
virus?
Lakshay, you want to run a program, fine, and by default a worm come in your system by default, and by default it start execution, means it is executing continuously जब वो execute करेगा, हर execution के साथ वो अपनी copy create करता जाएगा. So consider this as a similar to infinite loop, जहां पर आपका एक लूप है, चलता जा रहा है, चलता जा रहा है, चलता जा रहा है, चलता जा रहा है, इट इज नॉट एंडिंग. सो आपका लूप एग्जीक्यूट होता रहेगा, तो आपका सारा जो भी रिसोर्सेज है, आपके प्रोसेसर है, डेट विल बी ऑक्यूपाइड बाय डेट. सेकेंडली, जब आपका लूप बार बार एग्जीक्यूट होगा तो उसको मेमोरी में स्पेस चाहिए. सो इट विल कॉन्टिन्यूसली टेकिंग द स्पेस इन मेमोरी ऑल्सो. सेम वे आपका वर्म क्या करेगा, एक सपोज एक वर्म का जो साइज है वो 5 KB है. It is continuously executing. Next one take 5 KB, then next 5 KB, then 5 KB, 5 KB. कितने memory it will take? You cannot imagine. And sometime what happened? आपकी window crash होती है. Am I right? Sometime virus या
Yes, ma'am.
worms की वजह से आपकी window crash हो जाएगी. You have to reinstall. Why? क्योंकि आपकी memory completely full हो गई. Where your other program will reside? Or what they can cause, they can slow your speed, because in your processor is being occupied by such kind of works. So here, although this has been created with a negative way, like to to just decline the performance of the systems, but from here we have one idea कि if a warm kind of program can take the resources. The difference is worm, no one want a worm inside their system, but the conceptual idea is they are taking the resources. So why not a good program? Why not a program that is, other program that is created with good intention? Why not they can share the resource? Why not they can use the CPU cycle of your system? Why not they can use the memory of your system? Fine. So from there, the idea struck, why not we can have programs that are good in nature and that can, utilize the resources of other system. Fine. But worm, we are not considering it in a positive direction. Worm are like they are infinitely executing, they are infinitely creating their copies, they are infinitely taking the memory space in your system, they decline the performance of your system, and sometimes there is the crash in your system. And second important thing, they can travel from your system to other system also. Fine. So beta, we will continue from history again tomorrow in your next session. Before that, beta, just give me okay, you all can give, it's already 31. I'll mark your attendance, beta, by myself.